Hello, good day to each and everyone. We are once again gathered here for another lesson that we will be tackling specific to our discussions in earth science. In particular, for this video, we are going to discuss the exogenic processes that are happening in the earth's surface. In particular, we will be dealing with weathering and erosion. So sit back and relax and let's listen to our discussion for this video. Last time, if we could recall, our discussion was all about the different types of rocks, and we also talked about the processes that are happening in what we call as the rock cycle. So right now, we will be dealing with one of the exogenic processes that are happening on the Earth's surface, which is what we call as weathering and soil erosion, which is considered as one of the important aspects of rock cycle. So, without further ado, let us now begin with our discussion for this video. So, we will be focusing on this video on weathering and erosion. And in fact, weathering and erosion is a very typical process that is considered as an exogenic one. So when we refer or when we say exogenic process, that means that these are processes that are happening in our Earth's crust. So meaning to say, these are all processes that are happening on the surface of our planet. So in fact, many exogenic processes like the ones that you see in the picture right now are evident in the Earth's crust. Like, for example, I will just cite some examples that are usually found from other countries, like in the pictures that I'll be showing to you right now. Like, for example, the mountains carved by glaciers in Yosemite Valley in California. So, these are some of the features that are associated with weathering and erosion. And another one is the Grand Canyon in Arizona, which is still in the United States of America, which is believed that these features were carved out by the Colorado River. And another example that I can also show you would be the Bryce Canyon in Utah, which is still in the United States of America. And as explained, this feature was actually formed by the acidic rainfall, which has worn away many of these rocks are found on these mountains. And the harder rocks, of course, still remain standing, but we don't know how far will this feature will last, because you don't know that over some periods of time that these agents of erosion and weathering will still continue to hit these rocks. No, we don't know when these rocks will will last. So will they last forever? Well, that's a thing of time itself. We don't know the answer to that. But time itself will tell us that these processes, if they continue to happen, there might come a time that these rocks may not may not be found anymore in the near future. But anyways, let us now focus on our discussions on weathering and erosion. So let's first focus on some trivial definitions. So when we speak of weathering, this is either a physical disintegration or shall we say a chemical alteration of rocks at or near the Earth's surface. Now, when we say erosion, that means it's the physical removal and transportation, by the way, that's and transportation of weathered material by water, wind, ice, or gravity. Now, when we say mass wasting, that means it is the transfer or movement of rock or soil down the slope, and this is primarily due to the force of gravity. And lastly, when we speak of deposition, this is the process by which weathered and eroded materials are laid down or placed in a location that is different from their source. Now, these processes are considered to be very important especially in rock cycle, because over geologic time, weathering, erosion, and shall we say mass wasting transform these solid rocks into sediments and soil, and in turn it results to the redeposition of these materials, forming new sedimentary rocks. So that's why it's a very important feature in the rock cycle. So let's further discuss weathering. So when you say weathering, as discussed a while ago, it's either a physical disintegration or the chemical alteration of the rock particles. And this is due to the broken down due to the exposure of the processes occurring at the Earth's surface. And usually they are caused by water, waves, wind, gravity, and glaciers or ice. So just to remember this simply, you have the two G's and the three W's of weathering. Okay? Now, there are two main types of weathering. Number one, we have the mechanical weathering, or we call this as physical weathering, which rock is broken down into smaller pieces of the same material, and there are no changes in its composition. Now, in chemical weathering, the breakdown or decomposition of the rocks that occurs when minerals are changed into different substances, and that there is a change in the composition of the material, or shall we say the particles that have undergone weathering. So let's further discuss each of these types of weathering. First, let's go with mechanical or physical weathering. One type of physical weathering is what you call as the frost or ice wedging. This is a process in which water freezes in the cracks of rock and wedges, which pushes it apart, that causes rocks to split apart, because of course we know that water expands when it freezes. This is one of the anomalous behavior of water, because we know in the kinetic molecular theory we have learned that when matter undergoes solidification, that is um, solidification, or shall we say freezing, we know that when that particles contract, right? And that when it undergoes heating, we know that particles also expand, right? But in water, there is a certain temperature in water wherein instead of contracting at cool temperatures, water begins to expand. And these are some of the useful features or behaviors of water in our ecosystem, because without this anomalous behavior of water during winter seasons in other countries, especially those that are located in the northern hemispheres of the planet, marine life or animals that thrive on water may will not be able to survive without this particular behavior of water. Now let's go back to frost or ice wedging. This occurs where there are frequent freezes and thaws. Okay, so if you can see here on the next picture, this is what frost wedging is all about. So as you can see, when water seeps through the rock spaces, and when this water begins to solidify or freeze, this freezing of water causes its molecules to expand, which of course creates a gap along the rocks. So that's what you call as frost wedging. Okay, so moving on, frost or ice wedging can cause potholes to form in some pavements, but of course these features not so common in our setting, because we live in a tropical region. Now of course, in some other countries, these are happening. Another type of mechanical or physical weathering is what you call as abrasion. So this is the weathering away of rock material, which is caused by grinding action. And usually these are caused by sediments in wind, water, and in glaciers. Now let's further talk about abrasion. So we have wind abrasions, or we call it the sandblasting effect on the stationary rocks as seen in arches in the national park. So it is believed that this this arc feature in the arches in the national park, this is actually in the United States, no? that these arches are actually caused by the wind abrasion. So meaning to say these are caused by the actions of the wind. Okay, so another type is what you call as the hydraulic abrasion, or shall we say, the forces of the water that is moving. Okay, so there are water and sediments that are flowing over boulders, as seen here in the Ohio Pile State Park in Pennsylvania. So you notice the rounded river rocks. Now they are rounded because um, they are constantly being weathered by this running water. Okay, so another type of physical or mechanical weathering is what you call as caused by plants and animals. Of course, the most common one there is when plants' roots are found on rock particles, in which the roots, of course, they have the ability to grow, and as they grow, they tend to crack along the surface of the rocks. Okay, we call it also as the root pry or root action. And some animals also that dig holes, like the ones that you see here in the picture, can actually break also rocks. And of course, there are also other plants like algae, which can also um, algae and leeches, no, which also produces some chemicals that could cause weathering on the rock particles itself. We can think of many examples, but one factor that could cause mechanical or physical weathering is the action of plants and animals. As you can see here, tree growing out of rock in Shenandoah National Park, and that these tree roots also break up sidewalks. So that's why um, if you see here in some of the common roads here in Cebu or even in the whole Philippines, no, there are some roads where trees can just be found, and naturally, the roots of these trees can also affect the roadsides, which causes cracks along the pathways. So that's why they are also agents of weathering. So we also have another process which we call as exfoliation. Now, exfoliation is from the word exfoliate, meaning to say this is the gradual peeling of layers due to uplift and frost action, which is typical of the granite domes like those in Yosemite in US. Okay, now how does exfoliation happen? So, for example, in igneous rock, we have here what you call as the process of uplift and erosion. Now, what causes this uplift? Well, we know that there are forces that are also governing the movement of our crust, which causes a bulging effect on the surface. They call it as the uplift. And as this uplift and erosion happens, the expansion and sheeting of these rock particles causes these layers on the surface of the rocks to exfoliate or to peel. Okay, so that is what you call as exfoliation. So to explain further, when we think of exfoliation, just think of how your skin undergoes exfoliation when you apply some when you apply some do you call that kinds of chemicals that you apply on your skin to make your skin to blemish your skin. I don't know what's the exact term for that one. So that's how we can think of exfoliation. Okay. So another thing also that we could remember when we say exfoliation is that when we say exfoliation, these are also processes, okay, that occurs on intrusive igneous rocks or metamorphosed rocks, or shall we say rocks that have been metamorphed, that are exposed at the Earth's surface. And typically, this process doesn't happen instantly. They actually happen very slowly or very rapidly as a form of mass wasting. and that the large rock characterized by exfoliation are usually described as exfoliation domes, as you can see on the picture. They form like domes. Okay, so at the same time, um, to explain how this happens is that um, the pressure in a rock, or the pressure that is experienced by the rock itself, is released along parallel alignments on the surface of the bedrock, and layers of slabs of the rock along these alignments break off from the bedrock and move downhill by gravity. So typically there are forces also that govern this, and number one is of course the uplifting that causes the bulging effect of the exfoliation, and of course the expansion, and lastly the force of gravity, which causes the downhill movement of this um, rock. Okay, so that's what exfoliation is. So moving on, let us now go to chemical weathering. Now when we say chemical weathering, this is the chemical alteration of the particles of the rocks, or the breakdown or decomposition of rock that occurs when minerals are changed into different substances. Or shall we say, your keyword here is the change in composition. And usually this involves water, water vapor, acids, or oxygen. So these are some of the primary agents that causes chemical weathering along the rock particles. Now let's discuss what are these types of chemical weathering. So first, we have what you call as hydrolysis. So when you say hydrolysis, that means from the word hydro, it means water. So now, for in hydrolysis, we have carbonic acid in water which dissolves calcite. And this chemical weathering can hollow out underground caverns like those on the limestones and dolomite, both dissolve because they contain calcite. Okay? And that is due to the action of water itself. Okay? In particular, the carbonic acid in water. So how is the carbonic acid formed in water? Well, when you combine, let's just say, in our atmosphere, of course, one of the gases that are found in our atmosphere is, of course, we know that it's carbon dioxide, right? So when this carbon dioxide they combine with water, they form what you call as the carbonic acid itself, right? And of course, this carbonic acid affects um, limestones, and that they dissolve them. So that's why if our atmosphere is very full of carbon dioxide, which mixes with water in during the condensation process of what you call as the water cycle, if it develops into a phenomenon which we commonly call as the acid rain. And this acid rain is of course is of course an acid made up of carbonic acid, which is of course found in water due to the presence of carbon dioxide in the atmosphere. And this carbonic acid, when it goes to the surface of the limestones, it somewhat weathers the particles in this in these types of rocks. Okay, so that's why when there's acid rain, you will notice that those statues, mm, which I will show later, statues, they actually weather slowly over time because of the presence of these chemicals found in our acid rain. So as you can see here, from the weathering of the details of the statues and tombstones, right? Like for example, marbles and limestone. Okay. Now, another type of weathering is what you call as oxidation. Oxidation of minerals, like for example with iron, like those that are magnetite and pyrite, results in the formation of rust or iron oxide. And this is also the reason why the planet Mars is color red. And in addition, by the way, copper turns rocks into green. Okay, Like the mechanical action of rain works on the gray while chemical acts on the rain. Okay, on the red. Okay, so that's actually believed to be what caused the planet Mars to be color red. Okay, because of the oxidation of some of the iron-rich minerals that are found in the surface of Mars. So now, when we discuss about the rate of weathering of rocks, now, well, typically there are three factors. Number one, we have the surface area. Then number two, we have the rock composition. And number three, we have the climate of the area which we should consider. Well, for surface area, this is a very common sense. The larger the surface area, of course, since there is a large surface area, there are more particles to be weathered. So the larger the surface area, the faster will be the weathering rate or the rate of weathering. Okay. Now for rock composition, well, rock composition is relatively very easy to remember because we know that in rocks or shall we say in minerals, there we have a typical scale that we use, which is the Mohs scale of hardness, right? The harder the rock or the mineral, the more difficult it is to be weathered. And of course, the softer the rocks, the more easy or the easier it is to weather. And lastly, we have climate. Oops, sorry, I forgot to move my slides. Okay, there. So as you can see on this chart here, the higher you go to the index scale of hardness or the Mohs scale of hardness, the more difficult it is to weather. Okay, and of course for climate, okay, long-term pattern of moisture and temperature. Okay, the weathering rates are faster in warm, wet climates. Of course, for wet climates, of course, the moisture there can easily seep through the cracks of along the rocks, and the higher the temperature, the higher the rate of weathering happens. This, now let's go with erosion. So we discussed a while ago what is erosion. When you say erosion, take note of this. We have the keyword removal and transport. So a while ago we discussed about weathering. So when you say weathering, weathering is different from erosion because when you say weathering, it's the physical um, degradation, okay, or the chemical alteration, okay. So that's what weathering is. But when you say erosion, it entails movement. It's the removal and transport of weathered materials by natural agents such as, for example, glaciers, running water, gravity, wind, waves, or we can even include their humans and animals because of course ourselves we are agents of erosions. So let's discuss further about erosion. First, let's consider glacier as a an agent of erosion. When you say glaciers, these are mass of compacted ice and snow that moves under its own weight. So of course, um, glaciers are typically found on cold regions, shall we say, on the northern hemispheres and on the southern hemispheres, and of course, on those very tall mountains where temperatures are relatively cold. You can commonly find glaciers there. And glaciers, of course, they move under the influence of gravity. And when they move under the influence of gravity, they also carry with them some of the weathered particles along the rocks. And not only that, they also leave traces of their movements along the scratches that they make along the surface of the rocks. Okay, now the glaciers, of course, um, they leave scratches along the rocks through friction. Like for example, sorry, like for example, when glaciers move due to the influence of gravity, they leave scratches along the rocks, which we commonly call as the glacial striations. In fact, no, these glacial striations were one of the important um, evidences that were used by Alfred Wegener in his discovery, or not discovery, in his concept of continental drift theory, okay, which helped pave the way for the development of the modern day plate tectonics theory. And glaciers account about 75% of the fresh water on Earth. Yeah, that's true. Now, if we look at the water composition of our planet, we are typically composed of 70% of water, and of course 30% of land. But out of this 70% water, we only have, let's just say, 3% available fresh water. But out of this 3% water, around 2.97% of this fresh water is locked on glaciers and icebergs. Okay, that's why glaciers are a rich source of fresh water of in our planet. Okay. Now, glaciers can leave behind large boulders that we we typically call as erratic. Okay, so that's one effect also of glacier movement. So they leave large boulders which we refer to as erratic. Now, as what I've said a while ago, that glaciers move lots of sediments that carve striations or grooves into the rocks. Okay, that's what you call as glacial striations. Now, glaciers also, when they move, they deposit um, sediments, which we commonly call as drift or till, and they are deposited due to glacial activity. Now, one example of glacial drift or till or glacial deposits is what you call as this is read as less. Okay, these are fine powder pulverized rock that blankets much of the northern Midwest. So if you look at the um, picture here, we also have moraine, which are ridge or pile of boulders, gravel, sand, and silt left at the end of the glacier. So here, there we have here the terminal moraine here, this green part here, and we have also eskers, which are types of outwash that accumulates in the channels and tunnels of a glacier. So as you can see here, these are the eskers here. Okay, this one. So some of the common glacial landforms that are common in glaciers is what you call as the cirque, which are steep-walled ball-shaped depression here. And we also have the horn, which is a pyramid-shaped peak where three or more cirques meet. We also have the trough, which is a U-shaped valley, glaciers carved U-shaped valleys here. Okay. So we also have hanging valley, which is a straight drop off at the end of the trough. Okay. And we also have the arete, which is the narrow flat-topped ridge that forms between two parallel troughs or cirques here in this picture. Then when we discussed about this a while ago, moraine, which is an example of a glacial drift or till. These are actually pile of mixed sediments that have been carried and dropped by glaciers. As you can see here, this is actually a picture of a moraine, which is an aerial view of three glacial moraine ridges in Sedgwick. And the moraine in the upper right, which is this one here, next to the road, which is this one, okay, is oldest, and the glacier margin receded from right to left. Okay, as you can see there, that the glacier moraine receded actually from right to left in this picture. And we also have eskers, which are mounds of rocks that from melt tunnels. So where can you find the eskers here? Here, okay. The meltwater beneath the ice sheet tended to concentrate in subglacial tunnels, and as this glacier receded, some of the sand and gravel that washed through these tunnels was left behind as ridges called eskers. And Maine in US is geologically famous for its many eskers, which can be over 100 feet high and many miles long. So as you can see here, no? It's very long. Okay, this is an example protrudes over the adjacent Kezar 5 ponds in Waterford. So these are all found actually in in other countries, because of course glaciers is not so common here in our country. Okay, now let's go to streams and rivers as agents of erosion. Well, there are several factors that could affect the erosion of materials through streams and rivers, or shall we say water in general, the velocity of the running stream and river, or how fast the water move. The faster the water moves, the more force that it carries, and the more force that this water carries, the more it has the tendency to weather rock particles. Then we also have gradient. Okay, when you say gradient, that's the steepness of the slope that a river or stream travels. Of course, the steeper the slope, the more energy that this water will will gain, because of course we know that in our study in mechanics that the higher the elevation, the more potential energy certain material contains, and this potential energy, as they travel or as they move downward, they are converted into kinetic energy, and that this can be even described in the conservation of mechanical energy itself. So that's why the steeper the slope, the more energy that it carries, and the more energy that it carries, the faster it travels. The faster it travels, more force it also exerts, and the more force it exerts, um, more materials it could weather. Okay, so there's steep gradient, high velocity, and large discharge. Then erosion will be severe. Okay, and that rivers have energy to move lots of sediments and even large boulders. So that's why if you wonder why there are rocks, big rocks in particular, that are found on near rivers, falls, no, they might be carried along by these running water as they travel from a very steep slope. So that could explain also the presence of some of the big rocks that are found near the streams and rivers. Okay. Another thing that we should also discuss here is that river stages affect like velocity and gradient and discharge, which causes erosion. So as you can see here, um, we can actually determine if a stream is either young, mature, and old. Because if you look at the youthful stream, as you can see here, still so simple, right? Now, the mature stream is that the more water that flows, no, um, flood plains that it form will also get bigger. No? Now, when you say floodplain, these are areas where water would likely spill as a result of flooding. That's why it's called as floodplain. And here, old age stream, you can typically determine that a stream is very old by the presence of these folds here of your streams or rivers. Okay, so there, we just explained this a while ago. Upper part of the river has the largest bed load, more roughness, turbulence, and friction. But on the lower part is the greatest cross section, highest hydraulic radius, and greatest velocity and discharge. Okay, so as you can see here in the seven bends of the Shenandoah, um, which is typically called as the river meanders. These are the bends in the river that shows how mature a river is. So the more river meanders that you can see here, the more mature the river is. Okay, so that's how we typically identify if a river has been, not has been, but is mature or young or very old. So another type of erosion that we should also discuss here is what you call as mass wasting. Now, mass wasting is the downward transportation of weathered materials mainly because of the force of gravity. Okay? So, for erosion of mass movement or mass wasting, we typically classify them into these types. You have the creep, slump, mud flow or earth flow, and landslide or rock slide. So, these four are actually very different, which we'll be discussing later. Okay, so for example, um, when you speak of mass movement, usually we also call it in other terms as mass wasting. Okay, that's what we defined a while ago. These are large mass of sediment that drops down under the influence of gravity. Like for example, rockfall. Rockfall usually happens because of the steepness of the slope, where rock or debris falls along the steep slope. And then when you say slump or rotational slide, usually these are very common in areas that are, of course, elevated, and at the same time, usually these are caused by the presence of the water in the soil particles, same as with earth flow, mud flow, and debris avalanche. So let's describe them one by one. So when we say creep, okay, this is a very slow movement of earth material, and usually they are caused by the repeated freezing and thawing of the particles, and that the sediments that are loosened by expanding frost and contracting thaw causes this slow movement of the earth material. And you can evidently see this phenomenon in action, because you can actually observe it when, for example, there are trees that actually bends, or when electrical posts that actually bends because of the slow movement of these particles. Okay, and like for example, the leaning fence or posts and telephone poles are signs of a creep, like what we see here in this picture here. So if you are living on near mountains, you can, or you are living near mountainous provinces, no, where you can see some of these posts, no, located on the sides of the mountain. If you notice that these posts are actually leaning, that's actually a sign of a creep happening our in our uh, Earth's land masses. So another type of movement is what you call as the slump. Now, these are common in areas that are, of course, have steep slopes. This is a slow downward movement of a large mass of soil. And take note of this, occurs when underlying sediments are weakened by heavy rains, and that they are characterized by curved scar in the land surface. And usually they occur in like layers, okay, just like this. And sometimes these are associated with road hazards, especially on those roads that are located on steep slopes. Okay, so that's what you call as slumps. Now, mud flow, or shall we say earth flow, these are thick pastes of sediments that travel downhill at great speeds and usually occurs in dry areas that get a large quantity of water or rain all at once. And usually this leaves a cone-shaped deposit here. Like for example, here in the Blue Ridge, the Moorman's Gap near Charlottesville, as you can see here, this is actually now the evidence that a mud flow or earth thaw has happened here. There is a depression that is found already on this portion of the mountain. Now, another type of mass movement is what you call, of course, landslide or rock slide. These are fast movement of large blocks of rocks. No? It could be a rock fall or a debris fall, depending on the type of material that falls. Now, if a rock fall is mainly, of course, rocks. Okay, and for debris fall, this could be a mixture of rocks, soils, regoliths, in general. So it occurs only in very steep vertical cliffs, and these are accelerated by ice wedging. Now, as you can see, you might have observed in some mountains that they place like a barrier on the mountain, like a sort of a net. Yeah, that is actually to prevent this debris to actually fall and go to the roads, which might obstruct, of course, the passageway. So that's actually one of the preventive ways of minimizing the effects of rockfall, or shall we say landslide. Okay, so like for example, this is very problematic, of course. If this will obstruct the road, of course that will cause a lot of traffic jams in certain areas. Like for example, in Cebu, we have here many common areas that are very steep, like for those, for example, in Busay area, in Lahog areas, going towards those areas. No? These are areas that are very prone for these natural um, geologic hazards. Now let's move on to another type of erosion agent, which is wave erosion, which is still caused by um, water. Like, for example, the crashing of waves on a shoreline combined with storms continually shape the beach. And this is a shoreline with erosion, for example. In a shoreline, you can see lots of erosions happening. Like, for example, the formation of sea cliffs and formations of sea arcs. No? Like, for example, if this is the beach area, if this sea arc continuously erodes this arc here that is formed here, there will come a time that this arc will eventually break. Sorry, so it'll eventually break and form what you call as the sea stack. Okay, because the sea stack is when a sea arc is actually degraded and forms a separate stack of rock, which is what we call as the sea stack here. Now let me proceed to the next slide. How does it happen? Like, for example, in weak areas that are attacked by waves, open to form a cave due to erosion, or shall we say due to hydraulic action. And this cave widened and deepened by erosion, which forms an arc in the process. We call it as Durdle Door and Dorset. And as the roof of the arc continually undercut, it eventually collapses and leaving an isolated stack. So that's why the stack here is continually eroded, eventually forming what you call as a stump. This one here. Okay? This one. Okay? Now, wind and waves. So wind, of course, is a type of or an agent of erosion, which could also move rock particles from one place to another. Like, we can easily identify the effects of these wind erosion. Like, for example, the existence of what you call as sand dunes in the beach and in the deserts. Okay, so those are some examples. Winds also is a very strong agent of erosion, which can carve out landscapes as it carries sediments. No? As you can see, as evidence from this picture here, this is actually caused by wind erosion. And many storms um, combined water and wind to cause significant erosion or on landforms. Like, for example, strong winds are capable of moving large amounts of sediments. Like, example here, this is an example of a scenery from certain place in our planet. Like, for example, this is from January 2nd. When a storm hit their area, it eventually degraded all the land masses on this side of the road here, which eventually collapsed from January 2nd to January 24th. Okay, we have also many um, events here that happened in our place here in Cebu, specifically during the onsets of typhoons. Like, for example, in Typhoon Odette rather, there were many um, materials that were weathered away due to the strong winds and, of course, storm surges that struck the shoreline of some of the municipalities and provinces here in our province. So that's why they are very powerful agents of erosion when they are combined or when they happen all together. Now, another type of process which is considered as an aggregation process is what we call as the deposition, in which is the process of dropping or depositing soil and sediments. Now, this is a very important process in the formation of um, sedimentary rock because, of course, as the rock particles which were weathered away because of the physical or chemical processes, they will they will undergo erosion, meaning to say they will be transported from one place to another. And when they are transported in one place to another, they will also be deposited in a certain place, which we typically call as the deposition process. And deposition is very important. It's because it's where all these materials actually gather together, and through the process of what you call as cementation, it produces what we call as a new sedimentary rock formation. Okay, so that's why deposition is very important um, process in the rock cycle. Now, I will have to stop from here because this is typically the end of our discussion on weathering and erosion. Okay, so in our next topic, we will be dealing with soil, or the one of the effects of weathering and erosion. So we'll be discussing all about soil in our next video, but for now I am going to cut our discussion here because we will now be entering a new horizon for our next discussion for the next video that we will be producing later on. So I will have to stop my presentation here and we will end from there. Okay, so to summarize everything that we have discussed so far, we have different exogenic processes that help shape our Earth's crust. And these exogenic processes are also important processes that are found in our rock cycle. And these exogenic processes include weathering, erosion, mass wasting, and of course, deposition. And altogether, when these processes they happen together, they help shape our planet. And at the same time, they also help recycle all the minerals and some of the important um, chemicals that are very sustainable, shall we say, that will help sustain life in our planet itself. They are means of recycling nutrients, and at the same time, they are means of uh, transporting materials from one place to another, which can be used in order to form another type of rock, or some of these minerals can also be used by other organisms for very important biogeochemical processes. So that's why weathering and erosion, or shall we say the exogenic processes of our planet, is also one of the many important processes that happen along the Earth's crust. So we will end our discussion from there. So thank you so much everyone for listening to our discussion for this video. So we will continue our discussion as we move on to our next topic in the next video, which is all about soil. Okay, so we'll be discussing in the next chapter the different types of soil, as well as how a soil is formed and what is the importance of soil in our planet. So thank you so much, and God bless everyone. Hope that you have learned something out from our discussion on today's video. So thank you, and God bless you always. See you around when we see each other. Bye.